Hello guys, so today we are going to start a new tutorial series about how to create a landscape deformation system like this uh, using Unreal Engine 5. So let's start our tutorial series. In this video, let's see how to create the mask for this deformation. So first, let's delete these meshes and create a landscape first. Yeah, let's create. Let's delete these meshes also, we don't need them. uh, let's create a folder for our project, like landscape definition. uh, First let's create a material for this landscape. I will create this under this material folder. Let's just add the normal color for this for now. It's like brown, dark brown or something. Then let's assign this material to the landscape. Yeah, that's it. So this is how we are going to create this landscape deformation system. So to do that we need first let's create the blueprint for this is how this works. In here we have this landscape. Under the landscape we are placing a scene capture 2D component like this. It should facing upwards, so it sees the landscape like this. uh, the landscape should be two-sided, and uh, if we have some objects like this and these objects should have enabled their custom depth. So that's how this render target sees them, and the render target sees this with the custom depth like this. It can see this sphere like this, and this player's feet like this. So let's create this. To do that, first create a blueprint. uh, First we create a folder for blueprints, and create a create an actor blueprint for the BB capture. Now let's add this scene capture component 2D. We should create this rotation in y-axis and z-axis as 90, and we need to change this projection types as orthographic, and the auto it should be like this. So this scene capture component needs a material for this post process material to see the footprints from under the landscape. We should make this two-sided, and let's create another material for the post process of BP capture. And I name it as an object. Make this as post process. So let's create the scene texture. Take the custom depth here and let's duplicate this and select this as scene depth. So let's mask this from R. We need to mask both from the R. Then we need to subtract this custom depth from scene depth. And then we should divide it from some value. I'll add like 15. This is the length the scene capture sees from the surface. So let's add saturate and then 1 minus. Let's see how this works. Let's make this let's enable custom depth of this object. And let's try this post process material working on it by adding to here. Yeah, this is how it works. It sees only near the surface, so when it's moving, so we can also see that even it's moving. Yeah, that's it. So now let's assign this material to our scene capture component. Depth check, and we need the render texture for this as this texture target. So let's create it under this folder. Let's create another folder for textures. Create a render target like RT capture. Let's assign this to here, and we need to make this as final color. So we need to create a material function parameter for our project. Material parameter collections, my bad. MPC capture. We need a scalar parameter as capture size, so it will store the size of this scene capture component. And we need another vector parameter as capture location, so it will store the location of the player. And we need another scalar parameter as height. So in the event begin play, let's store the size of the scene capture component here. Set scalar parameter value to our material parameter collection mpc capture, then parameter is capture size. Let's take the size from the scene capture components. Get auto width, so this is it. So for now we are having this just base color landscape material, so let's add the modifications for this. Get absolute world precision node and then mask it from to RNG. Then multiply it from this vector 2 amount, and then add it to the capture size that we just created from here. And divide it from 2 by 2 and add it, and again add divide function, divide node, and add this capture size to here. And we need to create a custom node in here. Let's add the input as UV, and this output type should be float one. And let's create the function in here like this. If uv.x is less than 0, or uv.x is greater than 0, or uv.y is less than 0, or uv.y is greater than 1. This should be 1 also. And if it is true, it will return 0. Otherwise it will return 1. So when you are pressing enter in here, it will not go to a new line. So if you need the new line, so you can press enter by pressing shift key both. So we need the texture of RT capture, and then we need to multiply them and add 1 minus node, and let's see by connecting to base color. And so nothing working here because we didn't add any functions. So first we need to move so let's create a function for moving this capture under the player. Let's name it as move capture, and here and we also need another macro for snap like snap to a pixel size. We need 3 float inputs like player X and player Y, and for pixel world size let's divide this player X location from pixel world size and player Y also, and add flow node for both. And then we need to make a vector from them. Add the make vector node and connect here and connect this to here, and we need to add 0.5 value to this vector, and let's multiply it from this pixel world size, and let's return it. In move capture, so we need a variable like move offset. It's a vector 2D and we need to set value in this move capture function. So let's get player character and get actor location, and let's add this macro to here and connect them. And for the pixel world size, let's get this scene capture component and auto width, multiply it by dividing 1 by 256 and connect here. Let's add a subtract node from get actor location, so it will return the offset of the location, and then add that offset world offset And let's see it's working or not. Oh, I think I forgot to add the BP capture to the world. We need to place it in 0 location and set location like uh, minus 200 2000. mm. So let's enable our player mesh this custom depth by searching custom here. Now it will recognize this player's footprints, so I will show you like this here. And then let's create two colors for this to easily visualize easily. Let's add a blurb, interpolate. Oh, we should change these colors. Like this. So yeah, now we can see our scene capture is capturing the player's footprints, but in one area. So we need to move this capture, so that's why we are creating this move capture function. Let's see, let's try it's connecting to event tick. No, it's not moving. To do that, we need to store the players this offset to our material parameter collection as this capture location. So let's set vector parameter value for this material as capture location, and let's get vector location like as here, connect. And then in the landscape material, so we need to subtract this from the capture location, and let's connect this here. No, we need to first mask it. Now our capture is following the player, so but those footprints are not accurate like as our players feet. It's like pixels. So to get rid of that, let's add the spear mask. No, not a spear mask, spiral blur from a texture. So we need this texture as a texture object, and connect these UVs to here and create parameters for distance and distance steps, radial steps, and kernel power. If you don't know how to spawn these nodes easily, just press S, and while pressing S, press your left mouse button click, so it will add these parameters. Let's add the values for them. 0.01 as distance, 8 as distance steps, 4 as radial steps, and 0 as kernel powers. And let's connect them. And connect it to here. No, before connecting we need to mask it from red channel, and then let's multiply it from, let's create the material parameter like mask multiplier, and value as 3.8, and need to clamp it. Let's see how it's working. Yeah, now we have some blur effect from our player footprints. So now it stores only the player's live location, so we need to store player's previous footprints also. To do that, let's create another render texture to store the values like RT persistent, and we need to create a material for drawing the capturing location to the persistent. To that, let's create a material as draw to persistent, and we need to make it like unlit. Let's get texture coordinate, and we need to add offset to that. Let's add 4 vector and create convert it as parameter. We'll name this as offset, and then mask it and multiply it from 2 vector. Let's add -1 and 1 to here, and let's add, and we also need the custom function here. Let's just copy this in the landscape material that we have just created. and multiply it from this capture texture and connect it. In the BP capture, so let's create a dynamic material parameter, material instance from this draw to persistent material, and promote it as variable draw material, and then we need to create another function for this draw to persistent. I will name it as draw to persistent, and then this material, let's change the offset from this node. Parameter name is offset. Offset is just we just create this offset as 4 vector, and then let's get this more offset and divide it by the scene captures auto width. Connect it and connect get this draw material and draw it, this draw material to render target of this RT persistent we have just created, and let's connect this function to here, and in the depth check material we have created this for our these scene captures post process material, so we need to add the persistent render target to here. Let's get the red channel and saturate and connect it to this immersive color. Let's see, yeah, now it store the player's footprints also. Now we have a problem because when we play again it saved these previous footprints also, so to remove them we need to clear render target to the of this RT capture and persistent RT persistent also. Yeah, we can use new render texture. So I will end this video from here. So we have created this footprint mask in this video. So in the next video I will add a virtual heightfield mesh to deform this landscape. So thank you all guys for watching my video. Let's see in the next video.